Here we go. To do this, first we can change this into the matrix form and we'll end up with a 3 by 4 matrix. And whenever you have this kind of situations, ideally speaking, you want your matrix to end out like this. You want to have 1, 1, 1 right here, and then rest should be zeros, and then the last column right here should be the answers. Alright, and let me recommend you guys, you want to make this entry 0 first, and then second, and then third, and then fourth, and then fifth, and then sixth, like that, in this particular order. And I will demonstrate how this will work. So here we go. Of course, we can just write down the coefficients and also the numbers here to form our matrix. Have a look though. This right here has the coefficient 1. So I actually want to put this down as my first row so that I can achieve that, right? And let me just write that down right here. I'm just going to write down 1, 3, -3, and 4. And this is totally okay. When you interchange the rows of a matrix, the answer at the end will still be the same. Why? Because it's just like you write down this equation first and this equation second, and of course at the end the answers are still the same, right? Alright, then I'm just going to write that down, which is 2, 3, -2, and 4, and lastly 3, -6, 1, and -3. Okay, here we go. We got a 1 already. Now I want to make this entry equal to 0, and to do so I can just multiply everybody right here by -2. And some of your instructors might want you to show work things like this: -2 times R1 plus R2. I think it's okay. What I will do is I'm just going to multiply and then put down the results right here: -2, -6, and then 6, and then -8. It's easier for us to see when we combine, right? I think that would be better in my opinion. But again, follow your instructor if you are taking a linear algebra class. Alright, the first row stays because we haven't done anything with it. We'll just write it as 1, 3, -3, and 4. So combine this and that together, we get 0. This and that together, we get -3, and then +4. And this is -8 plus 4 is -4, like that. And now I want to make this equal to 0. Here we have +3. So I'm just going to take this row again, and I will multiply it by -3. This time I'll put on the result right here. We get -3, -9, +9, and -12. Have a look. This and that together, we get 0. This and that together, we get -15, and then 10, and then -15, just like that. So the first column is done. Now we want to make this entry equal to 1. So what we can do is, here we have -3. We can just take the second row and divide it by -3, or multiply by 1/3, same thing, right? And again, the first row will stay the same, and technically should draw arrows like this. And then let me just write down 1, 3, -3, and 4. Second row, we have 0, 1, and this and that is -4/3, and this and that together is +4/3. Alright, good. Now, here we want to make this equal to 0. In fact, I will use this row as how it is, so that I can actually just multiply by -5. 0 times -5 is just 0, so that doesn't matter. This and that together is +15, and then -20, and then lastly this is +20. Alright, so just combine. So 0 and 0 is 0, and this and that is 0, this and that is -10, and this and that is +5, like that. Cool. Now, so far so good, right? We want to make this equal to 1. This is -10. All we have to do is just take the last row and divide it by -10. So from here, we will actually write down the last row first. So the last row we get 0, 0, 1, and this and that becomes -1/2, like that. Okay, then just continue. I want to make this equal to 0, and I will actually use this row right here. What I can do is, because this is -4/3, let's just multiply this by +4/3. So we get +4/3, and this and that, we get -2/3 after you reduce. And then you take this, add it to them, and we end up with 0, 1 and 0, negative 2 over 3, and this is positive 4 over 3. They have the same denominator already, which is very nice. We get positive 2 over 3. Okay, so we got that done. Now we want to make this entry equal to 0, and we have negative 3. So I will take this thing right here again, multiply this by positive 3. So here we get positive 3, and this becomes negative 3 over 2. All right, now I'm just going to add these numbers to them. This and that, actually, so this and that becomes just 0. And this is negative 3 over 2 plus 4, which is the same as 8 over 2. So we get positive 5 over 2. And then we still have the 3 and 1, reading backwards like that. Okay, so just pay attention to the numbers in black. Lastly, we just need to make this entry equal to 0, and we will have to use a second row. All right, so I'm just going to keep the last row as how it is, 0, 0, 1, and negative 1/2. And then this row stays the same as well, 0, 1, 0, 2 third. But for this row, I will actually take it and then multiply it by negative 3. And I will get negative 3. This right here is negative 2. And then I will just add these two numbers to them. So I get 1, and then this and that is 0, and this is still 0. Lastly, negative 2 plus that is negative 4 over 2 plus that. So we end up with positive 1/2. So as you can see, we achieved what we wanted, right? So in this case, well, I will write down the answer for you guys. We have actually one solution situation whenever you have 1, 1, 1 like this. So one solution, one unique solution, and then let me just tell you the intersection of all this right here, and you see this right here are just 3 planes in the space. The intersection is just a point. Whenever you have just one solution for that, 3 planes intersect at one point. Very nice. Okay, and how can you write the solution? Depends on your teacher, or depends on whatever. You can write down x is equal to 1/2, y is equal to this, z is equal to that. Or you can also put it in the factor form, x, y, z. And I think this is how I'm going to present the answer for you guys. X, y, z. X is 1/2, and then y is 2/3, and lastly, z is negative 1/2. Just like this. And notice that when you have one solution, this right here, we actually do not have what we call the free variable. So let me just make a note right here. No free variable in our situation. I will demonstrate the free variable in the next example. And one last thing is that whenever you have one solution to your system, at least one, right? Sometimes you have a lot, infinitely many. You call this right here consistent. This is a consistent system of equation. So just kind of know the terms for that stuff. I think that's one of the hardest part of linear algebra because there are so many definitions that you have to know, right? So that's the first example. Now let's take a look at the second one. So for this situation, we still want to end up right here, right? But let's take a look what happens right here. First off, I'm actually going to write this down first, and in the meantime, I will actually divide everybody by negative 2. Why? Because this way, I do end up with the one that I want, and also we don't end up with fractions. So that's why I want to put this down as the first row, right? So here we go. We will have 1, and then negative 5, and then negative 6, and then negative 20. Okay, perfect. Now you know we can actually just put this down right here. But let's just save some time because you know that we will have to make this right here 0. So let's make that happen right now. Okay, have a look. If I want to make this equal to 0, well, we can just combine this and that together and then just put down the result right here. Let's do that. Negative 2 plus that is 0. And then this and that is 7. This and that together is 14. And this and that is 21. Okay? And then lastly, we want to kill this 5 and put it here, right? And what we can do is, I'm actually just take this row, and then I will multiply it by negative 5. Have a look. We will end up with negative 5, positive 25, positive 30, and then positive 100. And I will just combine this to that, which is 0, and then 16, and then 32, and lastly, we have 48. So that's what we have. So it depends on your teacher. If your teacher really wants you to write everything down as a matrix first, then go ahead and do that, and then just do that to your teacher, I guess. Okay, so we got the first column done. Now I want to make this right here equal to 1. Well, right here we have 7, 14, and 21, which is very nice because we can just divide everybody by 7 here, and no fractions, huh? Pretty good. Okay, so the first row stays. We have 1, -5, -6, -20, and then we get 0, 1, 2, 3. Perfect. Okay, now I want to make this right here equal to 0. This is 16, and what we can do is just multiply everybody right here by -16. So let's do that. Multiply this by -16. Or if you would like, you can actually divide everybody by 16 here, and then, yeah. Anyway though, you see this is -16, -32, and then -48. Combine to them, and then you see we get 0, and then 0, and then 0, and then 0. Very interesting. Now, in this situation, unfortunately, there's no way for us to end up with 1, 1, 1 right here because the last row is just all zeros, right? So here is a different scenario compared to the first example. We actually will have infinitely many solutions. And well, I cannot get rid of these two numbers anymore because I don't have any number in this entry, right? And you can also use some technical terms. We do not have a pivot in every row, but whatever. Oh man, but I think we can still make this equal to 0. So let's go ahead and do that. To do so, I will multiply this row by this is -5 already, so 5 is enough. So we get 5, 10, and then 15. So ladies and gentlemen, for this right here, I got a little arrow. Well, in the end, we see that we will just get 0, 0, 0, 0, and then 0, 1, 2, 3, which is pretty nice. And lastly, this becomes 1, 5, and that is 0, this and that is 4, and this and that is -5. So that's pretty much the final product that we have. Not like multiplication, but the final result that we have. Okay, so how are we going to interpret that? First off, we have infinitely many solutions. Right? Whenever you have 0, 0, 0, 0, you can just imagine you have 0x plus 0y plus 0c is equal to 0. And as you can see, that's always true. You have infinitely many solutions for this. And in this particular case, the intersections of all these three planes is a line. So I will just write this down right here for you guys. The intersection is a line. This is another situation though, but that will be later on. Okay, so we have this and that. In this case, we do have one free variable. So I will just write this down right here for you guys. One free variable. So you can see able. Yeah, one free variable, and the variable will be z. We'll just use z right here for the free variable because you can read this right here as 1y plus 2z equals 3. Similarly, you can also read the first row as x plus no y. That's why we want to get rid of that right here earlier. This right here is 4z, and we have -5. Well, move this here, we get y is equal to -2z plus 3, and likewise, we get x is equal to -4z minus 5. As you can see, x and y, they are based on z. So z is the free variable, name it whatever you want. Alright, and this is how you can write down your answer. You can write it as a solution set just by putting down the set notation, but I will just write this down for you guys. X, y, z. Well, what's x? X is that, so we have -4z minus 5, and then y is that, -2z plus 3, and what's z? Z is just z. Just like that. Okay, now I'm going to write down the constant first. So I will put down -5, 3, and 0. So this is going to be my first factor, and then I'm going to put down second factor that they all have the z. But I will write down the coefficients though. So I will just add this is negative 4, negative 2, and 1. And then don't forget to multiply by z, like this. And you can also just say z is a real number. Yeah, depends. But I think this is clear enough, right? If you don't put it in the set builder notation, the set notation, I don't think you have to do that. That's pretty much it. And notice that because we have infinitely many solutions, that means we do have a solution. So this system right here is consistent, right? But that's how you row reduce, and these are the interpretations for that result. Now let's look at the third example. Okay, are you guys ready to row reduce? I don't know, but here we go. So if you look at all this right here, unfortunately we cannot avoid fractions. So I'm just going to take the first equation as how it is, and then I will just divide it by 2, and that will give me the 1 right there, right? So here we go. First, we will have 1, and this is 15 over 2, and then we get negative 3, and then 8. So that's our first row. And then I want to make this right here equal to 0. What we can do is just look at the original equation right here, and then we will multiply everybody by negative 1. And when we do that, we can look at this as negative 2, negative 15, positive 6, and negative 16. And then just combine them. So you get this and that together is 0, this and that together is 2, this and that together is 8, and this and that together is negative 4. All right, now we need to make this equal to 0. Well, I will take this row right here, multiply it by positive 3, and add it to there. So multiply this by positive 3, we get 3, this and that is 45 over 2, and this and that is negative 9, and then 24. 8 and 24, Kobe Bryant, of course. Rest in peace, of course. All right. This and that together, we get 0, and this and that together, this is the same as negative 46 over 2, and that, so we get negative 1/2. This and that, we get negative 2, this and that, we get 32. Okay, so we got the first column done. Now, we need to make this right here equal to 1. And we can just do so by dividing the second row by 2. So, have a look. This becomes, we'll draw the arrows. The first row stays 1, 15 over 2, and then negative 3, and then 8. But the second row becomes 0, 1, 4, and negative 2. And lastly, we want to make this right here equal to 0, right? And we will actually multiply this by positive 1/2. So that you see, we get positive 1/2 here, and this to that is going to be 2, and this and that is negative 1. All right. This and that together, we get 0, and this and that together, we get 0. Negative 1 and 32 together, we get 31. Another strange situation, huh? 0, 0, 0, 31. In another word, 0x plus 0y plus 0c is equal to 31. Is that even possible? No. So this right here is actually an inconsistent system, and we actually do not have any solutions for this. And you can actually kind of just answer it, but you can also just keep on going depending on your instruction, I will say. Let's just see how we can keep reduce the fraction. One of the things you can do is divide this by 31, so you can make this equal to 1. That's pretty much what we can do right here. It's kind of cool, right? So let's see. I am just going to write this down here for you guys. We get 0, 0, 0, and then 1, right? Now, what I will do is I will multiply this by positive 2 and then add it to the second row right here. So I will multiply this by positive 2, and now that will just give me a 2. So 2 plus that is just going to be 0, and then the 4 stays, and then this one also stays, and likewise this 0 also stays. And I will multiply this by negative 8 and then add it to the first row. So multiply this by negative 8. I will end up with negative 8 right here. Plus that, we get 0, and then the rest stays, right? So we get negative 3, 15 over 2, and then 1, like that. What else can we do? Well, there's no way for me to make this equal to 0, likewise not, but we can make this equal to 0. And what we can do is just multiply this row by negative 15 over 2. And we get negative 15 over 2, and this and that. of course, you get the 2 reduced, which is going to be negative 30. All right, so let's see, the final result that we have is 0, 0, 0, 1, and then 0, 1, 4, 0. And for the first row, this and that is 0, the one in front, and then 0. This and that is negative 33, and lastly, we have that 0. So that's the final result, right? But anyway, 0, 0, 0, 1. This right here tells us that this right here has no solutions, and there's actually no point of intersection of these 3 planes. And again, when you don't have any solutions, this system is what we call the inconsistent, right? So that's it. Again, just know this situation, and there's one more situation that we'll have to go over. Have a look right here. Okay, so let's see what's so strange about this system of equations. Again, we want to make this right here equal to 1, and it seems like we can just divide the first equation by 4. So let's go ahead and do that, and we don't end up with fractions, so I am not worried about it at all, right? So divide everybody by 4, and we start with 1, negative 4, and then 2, and then this is 5. Okay, now we need to make this equal to 0, and here we have 2 already. So what we can do is, you can multiply everybody right here by negative 2, or you can just divide the first equation by negative 2, up to you. I will multiply everybody right here by negative 2. We get negative 2, positive 8, negative 4, and then negative 10. And then I'll take these numbers combined right here. I will get 0, and then 0, and then 0, and then 0. Seriously? Maybe just bad luck. I don't know. Alright, now we want to make this right here equal to 0. Okay, that's 5. So I'm going to multiply this by negative 5. And when we do that, we will end up with negative 5, positive 20, negative 10, and then lastly we have the negative 25. But if we combine this and that, yes, we have the 0 that we want, but this and that together is 0, this and that is 0, and then this right here, oh my god, it's just all zeros. The truth is, in fact, they are pretty much all multiple of each other, constant multiples of each other. And in this case, we are pretty much done in terms of reducing the matrix. And here we go. How many solutions do we have? You see, we have a row of zeros. That means we have infinitely many solutions. Infinitely many solutions. But in this case, the intersection, the point of intersection is a plane instead of a line. Because in this particular case, we actually have 2 free variables. So let me just write this down right here for you guys. 2 free variables. And I'm just going to use y and z. Have a look of the first row right here. We can read this as 1x minus 4y plus 2z is equal to 5. And I'm just going to kick this 2 to the other side. This is telling us that x is equal to 4y minus 2z and then plus 5. And then x and y are free, right? So you can see y and z are free, and x is based on y and z. And now if you want to write your solution, x, y, z. Well, x is what? X is all that, so we just put down 4y minus 2z and then plus 5. And what's y? Y is just y. What's z? Z is just z. Why? Because they are free. Alright, and now we again just separate them, right? And as you can see, right here, let me just put down the constant first, which is just 5 and 0, 0. So we write it as 5, 0, 0. And then let's put down the term that has the y. So this is 4 and 1. And then no y here, so it's 0. And then we have this factor times y. And lastly, just put down the ones that has z. So this, which is going to be negative 2, and there's no z, so it's 0, and we have 1 z. So that's pretty much it. That's how you can represent your solution. So again, this right here, because we have solutions, so this right here is a consistent system of equations. Now, one thing to note is that, remember from calculus 3, or maybe just like a general pre-calculus class or whatsoever, if you want to graph this equation, x minus 4y plus 2z is equal to 5. This is actually a plane in the space. And this is perhaps like the calculus way to do it, but this is like the factor way to represent the same plane. Pretty cool, huh? All right, so that's pretty much it. These are the situations that you encounter, and more importantly, this is how you should reduce the matrix, do the Gaussian Jordan eliminations and the stuff. And my goal is to make more algebra videos, well, linear algebra videos for you guys, and let's see how it goes, because I'm not teaching linear algebra, I'm just doing this on my own. So let me know, and if you guys would like more linear algebra materials, please check out Dr. Pan's channel, right? So as always, that's it.